Okay, guys, today we're going to try to measure the calories that are contained in a Cheeto with the pop can calorimetry. So, I've already measured out the first trial. 100 milliliters of water was put into the pop can. And we know that the initial temperature of the water is about 24 degrees Celsius. And so, for trial one, we're going to put 24 right there. We do need to get the mass of everything here because we're going to take the mass initially and the mass final and determine how much mass was actually burned. And so here we have 19.62 grams prior to the combustion. And then from here, we are going to burn the Cheeto. And the water inside of the can is going to be absorbing the heat that the Cheeto is releasing from being burned. So we're transferring the thermal energy into the can. The carbon soot that's being produced on the can is just a byproduct of the burning, and it's not going to affect the heat transfer. And so now, after the first trial here, we've burned the mass of the Cheeto. We're now at 18.82 grams after the combustion. From there, we can use a mass by difference to find out how much was actually burned. And we can see, we'll give the water a little stir inside of here just to make an equilibrium. And we see here that we're at about 38 degrees Celsius. We do know that the volume of water was 100 milliliters. And remember, milliliters is equal to grams, so we know the mass of water. So from here, we can actually use Q equals M times C for H2O. Remember, we want to use 1 calorie per gram degrees Celsius because we're trying to figure out the calories produced inside of the snack food for C. But we know the mass of water, and we know the initial and final temperature. And we can figure out the amount of thermal energy Q that was released by the Cheeto. So here we're going to reset for trial 2. We're going to make 2 trials here. And so we're going to dispose of the water that was burned or that was already heated. We're going to put fresh water in. And so we want to pour in new 100 milliliters. And reset the can here. So for trial 2, we're using 100 milliliters again. We do need to acquire the second Cheeto that we're going to put on here. So skewer that on there. And put our thermometer in to make sure that it gets an accurate reading of the temperature of the water. Give it a little stir to help. Now, the aluminum can itself, guys, aluminum has a really low specific heat, so it's going to gain and lose thermal energy pretty quickly. And so here, our initial mass for trial 2 is 20.18 grams. And keep in mind, I did leave that little bit of burnt part on the pie pan, which isn't going to affect the mass by difference of our Cheeto that was burned. And we might need to adjust the height. Yeah, we got a pretty good height there. So our thermometer has stopped moving. So now at trial 2, our initial water temperature is 25 degrees Celsius. And we're gonna go ahead and burn again. Oops, didn't quite get that wet. So see Cheeto burning again here, transferring the thermal energy to the water in the can. Again, the basis of this calorimetry is that the thermal energy is being transferred to the water. We know the specific heat of water, we know the mass of water, we know the temperature change for water, so we're going to take all of those and make the calculation for water. So here, final mass after being combusted was 19.02 grams, and our final temperature, boy, we got quite the raise in temperature there. However, we did have a longer burn time for the food. And we see that is at 47 degrees Celsius. So again, for trial 2, we're going to use the same formula. Q equals the mass of the water times the C for water times the change in temperature for water. And we'll be able to find Q, and then from there, we can take our 2 trials and average it. We can find the average mass of the food burned. Remember, this is going to be a mass by difference to find the amount of food burned, because this number here is the amount left over after the combustion. And then from there, we'll be able to actually calculate the calories per gram of snack food. Now, these calories are going to be physics calories, not food calories, right? 1 food calorie is actually 1,000 calories in physics, but you have all the data that we'll need in order to make calculations and complete the lab at this point. If you have any questions, please ask.